we continue revising, because it's important that we always revise and again, just keep on revising. Right. So we have a very good question before us, and let's try to go through even as we try to revise most of the week. Question number one reads that by the function you can see. And so the function is equal to 150 plus 4q plus 10q squared. In your analysis, you have to show all your working. What is the short run fixed cost and the short run average cost? How can you find the short run fixed cost? And how can you find the short run average cost? Hello? People are quiet. What is the short run fixed cost? How do you find the short run fixed cost? Given the function. Am I even logged out? Hello? Logged out, maybe.
Yeah, we are there. We are together.
Why not responding?
For me, I'm just doing something. I am on the meeting.
Okay. Anyways, since you don't want to talk, I'll talk alone since I'm used to talking alone. Okay.
No, be responding.
So the total cost function is given as this one, so we ask to find the fixed cost. So the fixed cost is the cost that does not change with the change in the level of output. So whether the level of output, let Q represent the level of output. So whether Q changes, then that level of cost remains the same, and that cost shall be called our fixed cost. So in this question, our fixed cost shall be 150. When you look at 150 in the function, it doesn't change with the level of output. Whether Q remains the same or Q changes, it still remains the same. Any question? Okay. Then you are given also to find the short run average cost. So the average cost, the short run average cost shall be given as the total cost, the average cost. So the total cost divided by the level of output. And our total cost is 150 plus 4Q plus 10Q squared. All that to be divided by Q. When you do all your divisions, you find 150 Q, because this Q here in the denominator is for everything, plus 4 and plus 10 Q, because one of the Q on 10, there are 2 Q Right. Yeah, so I was saying that the fixed cost is found by looking at the constant in the function. And so our constant in the function is 150. 150 is the one that is constant. So it does not change with change in the level of output. So that's about the 110. Then I did say that when you're finding the average cost, the short run average cost, the short run average cost is found by saying total cost divided by the level of output. So that will give you the average cost. And this shall equal the total cost 150 plus 4Q plus 10Q, that to be squared, and you divide through by Q. This Q we have divided here is for everything. The level of output is for both 150, is for 150, for 4Q, and for 10Q squared. So you shall have 150 divided by Q plus 4 plus 10Q. And that is going to be our average variable. This is going to be average cost, our average cost. Any question? Is that clear?
It is clear, even though you are a little bit breaking. I'm sure it's because of network.
You are unable to hear me?
Yes, from the definition.
Okay, so I said that the average variable cost, it is found by saying total cost divided by the level of output. That is what we said last time. So you're just dividing the total cost into like the output into the total cost. That gives you the average cost. And so this is how you find the average costs. Is that clear now?
It is now.
Okay. Right. If you have any questions, you can always ask your questions. We are trying to revise these same things. I know you might be aware of them already. It's your opportunity to ask, because if you just allow me speak alone again, as I have been presenting these things again and again for a long time. So it can be helpful for you to participate, ask questions, understand. Okay. It is okay. So we go to question number B. It says find the short run marginal cost function. So you have to find the marginal cost function. Now we said the marginal cost is found by saying change in the level of total cost divided by the change in the level of output. So it is actually the change in the total cost that is as a result of the change in the output. This can still be represented or can still be denoted by DTC, or change in total cost function, by divided by DQ. Now this DQ is a symbol for a derivative. That is to say, in the time when you want to get calculus to help you find the marginal cost, you can find the derivative of the total function with respect to Q, or the level of output. So basically what you're trying to do, since you're given the function here, you are differentiating this total cost function with respect to Q, right? Just finding the derivative of the same with respect to Q. Using the power rule, we are aware that when you differentiate the constant becomes 0. And this number like this one, where the level of output or the variable is just raised to the degree 1 or to power 1, you just get the constant or the coefficient of that variable. If you get the coefficient like this one, the variable here, which is Q, and our variable is just raised to the degree 1 okay, or the highest exponent is just 1. So in such cases, according to the power rule of calculus, you know that we said that you just get the coefficient. So our coefficient is 4 in this case. Plus here where there is 10 and the variable is raised to the power 2, you can drop the power 2 and then multiply by the coefficient 10. You keep the variable the way how it is, then the power reduces by 1. Okay. Just trying to remind you the principles of calculus. And so from there, you can say, you can have 4 here because 0 plus 4 is just 4. Plus 2 times 10 is 20 q. 2 minus 1 is just 1. So this will be your marginal cost function. Clear?
No, sir, come again.
Okay, so I was saying that for you to find the marginal cost function, you basically differentiate the total cost function with respect to output. So you are doing derivative, you're finding dy dx, just more like dy dx. Now this time you are saying dt c dq, right? So you are differentiating this total cost function with respect to q. That's what you're doing. We know that this one is constant, 150 is constant. Whenever you're differentiating constant, according to the power rule, we say that you get the constant, the answer is 0. When you differentiate the constant, the answer is 0. So when you differentiate any expression whose highest exponent is 1, okay, whose highest degree is 1, you just get the coefficient of that expression. For example, you have 2x. Your answer, your dy dx will just be 2. That's what we say. And if you have maybe 5x, your answer will just be 5, because this variable x is just raised to the degree 1. And therefore, where there is 4q, you just write 4. And then when it comes to this expression, whose powers are not, the power is greater than the 1. So the way how you derive this one, I said you drop the power and then you multiply by the coefficient here. Keep the variable the way how it is. Let the exponent reduce by 1. So 2 times 10 gives us 20 q to the power 2 minus 1 is just 1. That is how we got 4 plus 20 q. You got it? It's just calculus, like just apply the power rule of calculus and then you should be fine. There's nothing much that is done.
Okay, so the answer is just 20q.
It's 4 plus 20q.
Oh,
That's
sorry,
a
4
function.
plus 20q. That's the function.
Yeah.
Okay.
Okay. Find the short run average fixed costs. The short run average fixed cost. Now the average fixed cost is found by saying total costs divided by output, okay? The average fixed cost shall be found by saying total costs divided by output. If you can pay attention, you can realize that we are trying to revise on the cost theory of microeconomics. This is what we are trying to do. So what is our, average fixed cost is found by saying fixed costs, not total cost, sorry. Fixed cost divided by output, fixed cost divided by output. And our fixed cost, you said, is what? It's 150 according to this function. Our fixed cost is 150. It is the one that doesn't change with a change in the level of output, that divided by Q. So our average fixed cost shall equal 150 divided by output Q. Is that clear?
This paper was rather.
It was what?
I'll say it was
And the
something
paper
else.
was what? No, it was just as humble as all other papers.
Yeah, it was okay, but the way they brought my fixed cost, because us, we are used the way they bring it in the table. But now here, for example, you don't know anything and how we are going to identify those fixed costs in the party challenge. So, I was sure.
That's why the SAR is in class, to teach and explain all these things before.
And I tell you, we thank God for you.
The time comes. Another, oh, thank you. Thank you so much. And so this is what is there. So for the average fixed cost, just get it. Okay, like the formulas still remain the same, like those same ones that you know, that average fixed cost is found by saying fixed cost divided by output. It's still the formula. So the fixed cost we said is this one that does not change with the level of output, 150 divided by output. So our average fixed cost shall be 150 divided by output. Is that clear?
Clear.
Anyone with a question? Okay. These are purely examination questions, so at least it's better you see them from here. Short run average cost, average variable cost. Now, the average variable cost shall be found by saying variable cost divided by output. Every time you're finding average, you're just dividing by output. So the average variable cost shall be the variable cost divided by output. And by definition, what is the variable cost? Anyone to define the variable cost for us? What do you understand by the variable cost?
These are the costs that can change, anytime.
Okay. Okay, thank you.
Yes, for example. Okay.
For example, what?
For example, if they want to increase the production of productivity, what they will do, they can be increased or they can be changed, unlike for the fixed cost.
Oh, okay.
Something like that anyway.
That is interesting. Do we have any addendum or subtraction or any other comments on the variable costs? What are the variable costs?
May I try?
Yes, sir.
These are costs that changes with the. These are costs that changes with the level of output.
Okay, thank you. So the costs that change with the change in the level of output, right? When the level of output changes, also those costs do change. In short, they are influenced by the level of output. They are determined by the level of output, or the level of output has an impact on them. They are called the variable costs. Once you increase or reduce the level of output, they do indeed change. So in this question, you can see that the level of output, the only part of this total cost function that we have, 150 plus 4q plus 10q squared, the only part that can change with the level of output is this one that has got q. This is the only part that can change with the level of output. The 150 we said is fixed. It doesn't change with the level of output. So therefore, you shall have 4q plus 10q squared to represent the variable costs. So now the variable cost function is given as 4q plus 10q squared, 4q plus 10q raised to the second degree, and divide that by output raised to the degree 1. So this q, the output, the denominator is for 4q and for 10q squared. So when we divide q, our average variable cost shall be 4 plus 10q. This is because there are 2 q's on 10, and one of the q shall cancel with the q in the denominator. Any question? Are there any questions? Okay.
But how come, sir, anyway, how come this function it was for the marginal cost, again, it has come to average variable cost?
No, the marginal cost was
4 plus
which
10Q.
one? How was the marginal cost?
For marginal cost, it was 4 plus 10Q.
Mm-hmm.
Yes. And then I'm surprised, even for variable cost, it's the same.
Okay. Now, this is actually the mathematical proof of what we said the last time when I was teaching you the graphical representation of the cost. If you can remember how these graphs behave when you plot them on a graph, you see that the average variable cost is U-shaped, isn't it?
Yes, sir.
I apologize. I was locked out by this network of theirs. Someone was asking about why is the marginal cost equal to the what? To the average variable cost. Is it what you said? Hello? Vivian was asking that marginal cost is equal to the average variable cost.
Yes, sir.
Yeah. Now, the minimum of any function, once you optimize any function, you optimize the function by finding its derivative, okay? So if you find the derivative of the variable function by finding the average variable function, okay? When you just derive the total cost function to find the marginal costs, and then finding the average, okay, the average of the total cost function, finding the minimum thereof, it shall cut the marginal cost cuts the average cost at its minimum, which means at some point they are equal, right? The average variable cost at its minimum, they are equal with the marginal cost. Just the confirmation of that graph which you were drawing those days. So at some point, here where it cuts, they are equal at the minimum point. So when you minimize the total cost function, that's the marginal cost, then you find that it is equal to the average variable cost, and that is what is there. Okay, a good question it was. Find the short run average total cost function. So we want the average total cost, function, or the AC, which is just the total cost function divided by what? The total cost function divided by output. That's the average total cost function. So the total cost function in question we said is 150 plus 4Q plus what? Plus 10Q squared to be divided by Q, so that you can find 150Q plus what? Plus 4 plus 10Q, because you're going to divide by Q throughout. Is that clear?
Come again.
The average total cost is found by saying total cost function divided by output, okay? The total cost function divided by output. And so the total cost function, is the one that we have in question, 150 plus 4Q plus 10Q raised to the second degree, and divide that by output. When you divide by output, it means you have found the average thereof. You okay?
Yes, sir.
Okay. Finally, how are you?
I'm good. I'm following. I've seen you've cancelled there the queue. I've understood.
You will be fine. You will be fine. Okay. Question number 2 is here where you are given the table. People are saying we are used of the tabulated data. So the above illustrate the long run total cost faced by a firm. Can you find the long run marginal cost and the long run average cost faced by the firm? So we want the marginal cost and the average cost. Right. We want the marginal cost and the average cost of the of the same firm. So marginal cost, let's start by marginal cost, then we find the average cost. How do we find the marginal cost? We said the one that is tabulated. Marginal cost is found by saying change in total cost divided by change in what? In output. That's the formula, which is also equals to DTC dq. That is if you use calculus. We use calculus for functions when you're given a function. But here now, since we are not given a function, we're going to use this, the one for the numbers. So the change in total cost is equal to total cost 2 minus total cost 1 divided by output 2 minus output 1. That could be represented, or it could represent the change in output. So let's look at that now. So the total cost function at the first level of output shall equal the marginal cost. At unit number 1, the first level of output, marginal cost shall equal total cost. Okay, it shall equal total cost. So you'll have 120 here. Then to find the marginal cost here, you say 112 minus what? Minus 102, which is the total cost 1, divided by output is 2. Output 2 is 2 minus 1. And that gives us what? What do we find as the marginal cost?
Mhm.
What is the marginal cost? 112 minus 102. Divided by 1.
It's 40.
112 minus 102.
10.
102
100.
minus 102.
Oh,
It's
100.
The answer is 10.
Is 10. Okay. Then you go to the third unit. Third unit, you say 136 minus 112. 136 minus 112. Okay. So what is 136 minus 12? Divided by 3 minus 1. You know, the change, which is the change in the level of output.
12.
It is 12 still. Is that true? That 136 minus 112 is 12.
It's, you said 20. You said after we find the total, after subtracting, you said divide by 3 minus
3.
1. So you found the
Yes.
24. You divide it.
No, not the minus 1. Sorry, 3 minus 2. 3 is the output 2. Then the output 1 is the previous here. 3
So
minus
24.
2 is 24.
Yes.
Okay. Then 180 minus 136 divided by 4 minus 3.
143.
180 minus 136.
180 minus 136. It's 44.
44 divided by 4 minus 3 is still 44. And then you say 250 minus what? 180 divided by 5 minus 4. And what do we find?
70.
70. Okay. And 352 minus 250.
102.
Okay, 102. And we go ahead, 492 minus 352. 492 minus 352. We're finding the marginal cost function in the long run. What are you finding?
140.
140. Okay. Then 676 minus 492. What are you finding?
184.
184. All right. What about 910 minus 676?
234.
234. What about 1,200 minus 910?
290.
290. So that is what happens with the marginal cost in the long run. Is there any question? Any question? No question for the marginal cost. We can go to the average cost now. The average cost, the average total cost we said is found by saying what? Total cost divided by output, isn't it? That's what we said. The average cost is found by saying total cost divided by output. So 102 divided by 1 shall be what? Shall be 102, isn't it? And 2 into 112 is what?
56.
56. So that 3 into 136 can give us how much?
45.33.
45.3. And 180 divided by 4.
45.
45. And 250 divided by 5.
It's 25. Is it?
Are you using the calculator?
50.
Okay. 50 and 352 divided by 6.
58.67.
58.67. And what about 492 divided by 7?
70.229.
70.29 or 0.3. Okay. What about 8 into 676?
84.5.
84.5. 84.5. Right. What about the other one?
101.
101.11. 0.1. And the last one?
220.
10 into 1,200.
120.
120. Right. Is there any question? Hello? Okay. Are there any questions? People have not questions. Mhm.
We have understood, sir.
Okay. Now that people have not the questions, then we can go further. The question continues, says, plot your long run average cost and long run marginal cost spaced by the firm. So you can plot these along the using the same level of output. The same level of output upon the x-axis, this one. So now the easiest way on how you can plot this, I'm telling you that the level of output should be horizontal, then the cost should be on the vertical axis, and then put on a scale, maybe of 20-20, or maybe of 50-50. Yeah, 50-50 can actually do, and then you will be fine. Any question? You can plot all of them against the level of output, and then the graph will come out. Yeah. Then why does the long run marginal costs cut the long run average cost at its minimum? Just a question that one had asked it previously. Why is that the case? Okay. Why is that the case, that marginal cost cuts the average costs at the minimum here? Right. Why is that the case? Right. Why is it the case? Right. So as marginal cost is increasing, usually as marginal cost is increasing, before it reaches the average cost, the average cost is usually decreasing. And when the marginal cost is greater than the average variable cost, the average variable cost will start increasing. You are not getting what I'm saying. I am saying that when the marginal cost is less than the average variable cost, okay, is it the average? No, the average cost, then the average cost is decreasing. As long as the marginal cost is less than the average cost, then the average cost will be decreasing with the increase in the level of output. As the level of output is increasing, then marginal cost is less than the average cost. The average cost shall decrease to follow the marginal cost. Then when the marginal cost is greater than average cost, okay, then the average cost will start increasing. That is why it cuts it at its minimum. So from if you want to explain it from the business point of view, you can say that as the company is actually increasing its sales or the levels of output, usually the average increase, the cost will usually start decreasing as the level of output is increasing. The average one starts decreasing, but only up to a certain point. Okay, only up to a certain point. There will be a point again beyond which that the cost will start rising, and at that point, we mean that the economy or the firm is experiencing diseconomies of scale. Understand the issue of the economies of scale and diseconomies of scale. The economies of scale referring to the advantages and the benefits that the firm can enjoy due to expansion, and the add that the average cost is decreasing. Usually it is decreasing as the firm is growing. But the diseconomies of scale will come in, of course, after some point, as when the firm expands too big, such that the cost, again, the average variable cost will start rising in the future. And we say that the firm is experiencing the diseconomies of scale. So due to economies and the diseconomies of scale, you can even say that the average cost is U-shaped. I've even given the answer to the question. Sometimes you may ask it the question, why is the average cost U-shaped? Okay. If you can be given that, I've already explained that that is due to the economies and the diseconomies of scale, or it is due to the diminishing returns to scale. Still the same thing, and you can still get the full marks. Clear? Right. Using explain the perfect competition, firm decides whether to produce. Okay. Now the conversation to be continued.